Welcome back. We're on video 5.4. So remember back to Bohr's model of the atom, and that the lowest allowable energy state of an atom is called the ground state. What that means is the electrons are going to be on the lowest rungs of their orbits that they can possibly be in. When atoms gain energy, the electrons gain that energy. And when the electrons gain that energy, they hop away from the nucleus because they have more energy. So think about it. When you get money, you may decide that you and your friends are going to go hang out in the Brentwood Sonic. But when you lose money, or you've spent all your money, then you have to go back to the nucleus and you have to go back home and get more money. So when an atom gains energy, it's in an excited state. So if you look right here, in the ground state, the electron is on the first rung. In the excited state, the electron is on the second rung. It has hopped up. So, why does this matter? Because if you look at hydrogen, it's only got one electron. In the ground state, it's going to be where n equals 1. And remember, n is just that first circle, or first orbit. When energy is added, the electron moves to the n equals 2 orbit where it has hopped up. So what happens is we have the three different series. We have the ultraviolet series, which is called the Lyman series. We have the Paschen series, which is the infrared series. And then we have the visible series, which is the Balmer series. So what happens is as an electron hops up, if it hops up to one energy level n equals 2, and then it falls back down to n equals 1, under the visible series, right there, it's going to emit red light. If it hops up to n equals 6, and then falls all the way back down to n equals 1, under the visible series, which is the Balmer series, it's going to emit purple light. So, what Bohr did is he predicted the frequency lines in hydrogen's atomic emission spectrum. So, if you give hydrogen so much energy that its one electron has hopped up to the 6th energy level, when it gets down to, when it loses that energy, and that electron gets back down to the 1st energy level, and earlier I misspoke, second energy level, not first energy level. It's going to emit violet light. If it has hopped up to the 5th energy level and falls back down to the 2nd, it's going to emit a blue light, and so on and so forth. So it depends on how much energy that hydrogen atom has absorbed, and then when it falls back down, what color light is it going to give off? Now remember, the atom absorbs the energy. The electron is what moves between the ground state and the excited state. So remember that neon signs, they have neon in them. And the way that they emit light is that electricity is passed through that tube. That tube is filled with neon gas. It excites the neon atoms. When those neon atoms are excited, they are going to emit light to release energy. So when they emit light to release energy, those electrons are going to fall back down to the ground state. They would then have to be re-excited or get a lot more of energy to do it again. So, if I took hydrogen gas and I excited it by running energy through it, or electricity through it, it is going to emit light. And when it runs through a spectrum, a prism, that prism is going to separate light into its components upon a spectrum. And hydrogen's atomic emission spectrum is almost always going to end up giving you violet, blue, turquoise, and red light based on the length of the wavelength. So, if you look at this, I can always tell that it's hydrogen because it's always going to have that same atomic emission spectrum. So it's a set of frequencies of electromagnetic waves that are emitted by the atoms of the element. So each element has a unique atomic emission spectrum, and we're going to see that when we do the flame test lab. So thanks so much for your attention, and get ready to light some things on fire when we do the flame test lab and see what colors they turn.